The tank, a metal behemoth of modern warfare, is a symbol of raw power and strategic dominance. At its core lies a crucial component, the main gun. This barrel, often exceeding the length of a car, is the tank's primary weapon. It dictates the vehicle's firepower and ultimately its role on the battlefield. The evolution of tank technology has seen a fascinating dichotomy in barrel design. Rifled and smoothbore. Rifled barrels with their spiraling grooves were once the undisputed champion, offering superior accuracy at longer ranges. Smoothbore barrels, devoid of these grooves, were initially relegated to less sophisticated weaponry. However, the emergence of new technologies and changing combat dynamics brought smoothbore barrels back into the limelight. This resurgence was fueled by their ability to fire a wider array of ammunition, including high-velocity anti-tank rounds. The choice between rifled and smoothbore barrels is not merely a matter of preference. It profoundly impacts a tank's tactical capabilities and its effectiveness in various combat situations. Understanding the nuances of these two technologies is crucial for grasping the evolution of armored warfare and its future trajectory. Rifled barrels, characterized by their internal helical grooves, impart a spin to the projectile. This spin stabilizes the projectile in flight, much like a spinning top. The resulting gyroscopic effect enhances accuracy, particularly over longer distances. Rifled barrels excel in engaging targets at range and delivering pinpoint strikes with high explosive rounds. This makes them suitable for scenarios demanding precision fire support or engaging fortified positions. Smoothbore barrels, lacking these grooves, fire projectiles without imparting spin. While this may seem detrimental to accuracy, it allows smoothbore barrels to achieve significantly higher muzzle velocities. This is crucial for modern anti-tank rounds, such as armor-piercing, fin-stabilized, discarding, sabot, PFSDS rounds. These rounds rely on kinetic energy to penetrate armor, and higher velocity translates to greater penetrating power. The absence of rifling also reduces barrel wear and tear, resulting in a longer lifespan and lower maintenance requirements. Smoothbore barrels are less susceptible to fouling from propellant residue, further simplifying maintenance. This robustness makes them well suited for the rigors of modern combat operations, where reliability is paramount. The choice between rifled and smoothbore barrels directly dictates the types of ammunition a tank can employ. Rifled barrels are typically used with high-explosive HE rounds, armor-piercing AP rounds, and high-explosive anti-tank heat rounds. HE rounds are effective against infantry, fortifications, and lightly armored vehicles. AP rounds are designed to penetrate armor, while heat rounds utilize a shaped charge to create a focused jet of molten metal that can pierce even thick armor. Smoothbore barrels, on the other hand, are primarily associated with APFSDS rounds. These rounds consist of a long, thin dart made of dense material like tungsten or depleted uranium. This dart is encased in a sabot, which separates after leaving the barrel, allowing the dart to travel at incredibly high velocities. The kinetic energy of the dart upon impact is immense, capable of defeating even the most advanced armor systems. Smoothbore barrels can also fire high-explosive anti-tank heat rounds, although their effectiveness is generally lower compared to APFSDS rounds. The absence of spin stabilization can hinder the accuracy of heat rounds at longer ranges. However, they remain a viable option against lighter armored vehicles or in close quarters combat. Section 4, From Smoothbore to Rifled, A Historical Journey. The early days of tank development saw the dominance of smoothbore cannons. These cannons, often adapted from existing artillery pieces, were relatively simple to manufacture and maintain. However, their accuracy at longer ranges was limited by the lack of spin stabilization. As tank technology advanced and combat ranges increased, the need for greater accuracy became evident. The introduction of rifled barrels in the mid-19th century revolutionized artillery, and this technology soon found its way into tank design. Rifled barrels offered a significant improvement in accuracy, allowing tanks to engage targets at greater distances with greater confidence. This shift towards rifled barrels marked a turning point in tank warfare, enabling more precise engagements and extending the effective range of tank cannons. However, the emergence of advanced armor technology in the latter half of the 20th century posed a new challenge for rifled cannons. Traditional armor-piercing rounds fired from rifled barrels struggled to penetrate the increasingly thick and sophisticated armor of modern tanks. This led to the resurgence of smoothbore cannons, specifically designed to fire high-velocity APFSDS rounds capable of defeating these advanced armor systems. Section 5: Impact and Future Trends. The adoption of smoothbore barrels for main battle tanks has significantly impacted modern military strategies. The ability to fire high-velocity APFSDS rounds has given tanks a decisive edge in armored warfare, making them potent tank killers on the battlefield. This has led to a shift in tactical doctrines, emphasizing maneuverability and rapid engagement at longer ranges. The focus on smoothbore technology has also spurred research into new ammunition types and barrel materials. Developments in composite materials and advanced manufacturing techniques have led to lighter and stronger barrels, capable of withstanding the immense pressures of firing high-velocity rounds. Research into new types of kinetic energy penetrators and explosive warheads continues to push the boundaries of tank firepower. Emerging technologies, such as electromagnetic railguns and directed energy weapons, hold the potential to revolutionize tank armament in the future. Railguns utilize electromagnetic forces to launch projectiles at hypersonic speeds, offering unparalleled penetration capabilities. Directed energy weapons, such as lasers and high-powered microwaves, offer the potential for precise and instantaneous target engagement. Section 6: Conclusion. The evolution of tank barrel technology from rifled to smoothbore reflects the constant adaptation of military technology to meet changing battlefield demands. While rifled barrels excel in precision and versatility, smoothbore barrels dominate in armor penetration, shaping the landscape of modern tank warfare. As technology continues its relentless march forward, we can expect further innovations in barrel design, ammunition types, and perhaps even entirely new forms of tank weaponry, forever changing the face of armored combat.